Hello and welcome to this 22-minute webinar series, Designing for the Internet of Things. I'm Jeremy Rigneris, Product Introduction Manager here at SolidWorks, and we're going to spend the next 22 minutes talking about what it means to design for the Internet of Things. Throughout the presentation, please feel free to tweet about what you've seen here and share it with others using the hashtag provided. And before we get started, I want to look at a couple of housekeeping items. When using GoToWebinar, you're going to want to use the control panel provided on the right-hand side of the screen. Here's where you can ask questions which we will answer to the best of our ability when we get to the end of the presentation. Now, throughout this presentation, we're going to be asking several poll questions. Let's go ahead and start with the first one. Is your company involved with connected devices? This could be anything from simple devices that have some sort of a web interface, or they're connected through human input, or a variety of other means. I'll give you a few moments to answer these questions. Alright, so it looks like about 32% of you are working with connected devices. That's great, as it means the content we're going to be reviewing today will be good and relevant. So let's quickly take a look at what we're going to be discussing. First, we're going to look at what the Internet of Things is. This is a buzzword that's very popular today. And we'll talk about designing a smart object. Then we'll get into workflow, what that typical workflow involves, and then how SolidWorks fits into this workflow. And then we'll take a look at a demonstration of how SolidWorks actually you would design a product for the Internet of Things. And then finally, we'll answer some questions as they come up throughout the webinar. So let's go ahead and let's start with what is the Internet of Things. The Internet of Things is basically a series of objects that can interact with each other using the Internet. They are constantly capturing information from their environment, so they're aware. They allow you as the end user to provide input or controls into that. And we're going to take a look at a few examples of typical objects that you might see today that fall into this category. But realistically, all these objects are connected, and they have the ability to both interact with you and the environment around you. So designing a smart or connected objects involves a couple different aspects. There's the device itself. For example, a pedometer, which you might use while you're going for a walk or a run, and you want to capture your level of progress throughout your run or your walk. There's typically usually a web interface where you can review the results or where the device connects to and provides a user interface for the user. And there's also apps. Most people carry a smartphone around today, and these typically provide an alternate way of communicating or interacting with your smart device, or the device itself has a UI or user inputs available to it. So here's a couple of examples of some internet connected devices that you might see today. So Fitbit is a SolidWorks customer who they create wireless trackers, things like the pedometer that I just mentioned, a smart scale, and they provide a whole solution for fitness where they provide a web browser interface where you can interact with the results from things such as your walk, weighing yourself, etc. And Nest is another great SolidWorks customer, really well known for the Nest thermostat, which is a thermostat that interacts with its environment around it to understand if people are there, how the temperature should be adjusted, but also while you're away gives you the ability to provide input, such as changing the temperature of your home while you're not home. So when we design for this IoT ecosystem, there's a couple different areas. We discussed there's the physical product, and then there's also web design and apps design. And each one of these encapsulate different disciplines of design. What we're specifically interested in looking at here today is this first step, the engineering design. This is going to include everything from CAD, electrical and electronics, and it's going to be the mechanical and electrical engineers interacting with each other. That's not to say that SolidWorks doesn't interface or provide output that's usable from web designers and apps, but the disciplines we're really going to look at are going to be these first steps here. So as we get into that, let's look at what the anatomy of an IoT device might consist of, and why is it important for the design aspect. You might think it's just an object that just needs to communicate. Well, you have to have the physically appearing aesthetics for the object, in this case the outside shroud. You also have to have user input in some cases. In this case, again, that outside shroud provides a dial mechanism where users can go in and they can make adjustments to the temperature. But more than that, the device is aware of its surrounding. For example, this device has a motion sensor built into it, which understands when people are in the room around it. It will then make adjustments based on inactivities. For example, if you leave the home, the thermostat actually recognizes this and it'll turn the temperature down. When you return, it'll bring it back up, or vice versa, depending if it's cold or hot out, whatever temperature you desire. But then there's also things such as the Wi-Fi antenna. This needs to connect out to the internet. And then finally, there's all the other components that make this up. There's the mechanical devices, there's the PCB boards, etc. And then, as mentioned, these connect to the outside world through the use of a mobile application or a web interface. So enabling these requires the collaboration of a lot of different disciplines. So for example, we discussed the electronics and mechanical systems working together, or the mechatronics systems. This is a great area where we're going to see in a moment where SolidWorks really comes on board. But you also have these other disciplines such as the human interface displays, sensing equipment, RFID sensors, etc. And all these need to be integrated. And this usually means that you're working with both electrical and mechanical engineers. So let's go ahead and let's ask another quick question. Does your company develop IoT technology? I'll give this a few seconds and then we'll go ahead and take a look at the results. All right, it looks like most people on the webinar aren't today, or if they are, they're using commercial off-the-shelf items to accomplish these goals. That's important because a lot of times you are going to integrate with outside resources and you need to integrate them into your designs. So let's look at the typical developmental process for designing this. Normally, it's a serial process. And what do we mean by that? Well, first there's the electrical engineers define the schematics or the electrical characteristics that are going to make up this device. Those are then integrated into the mechanical design where they need to be basically shoehorned into the design, or the mechanical engineer needs to design around it. This often requires going back and forth between the electrical engineer and the mechanical engineer. Then it's integrated into the design, as we mentioned, so things like wiring and things like that are then brought on board afterwards to see how they fit. A lot of people have seen the running a piece of string through a design to see how long an electrical connector needs to be, or electrical cable needs to be. In this case, you're waiting for physical prototypes to be made after the mechanical design phase. Then final documentation for these nail board drawings and so forth need to be created. And then the operations and production of the devices ends up being created. Well, how does SolidWorks fit into this? One of the things SolidWorks really focuses on is streamlining this entire process and getting these disciplines working together much earlier on in the design phase. This way, the mechanical engineer can work bi-directionally with the electrical engineer, and things such as wire harnesses can be integrated right into the design. This greatly reduces the overall time to finish production, which basically means you're getting your product out the door faster, which results in higher productivity gains. So, let's ask another question here before we move on. What is your readiness today to deploy IoT tools? Are they in place, in development? Are you investigating IoT, or do you have no plans at all? Again, I'll give you a few moments to go over these and answer these questions. All right, it looks like the majority of people don't have any plans today, but a lot of people are investigating deploying IoT solutions. And then again, this is important to make these decisions early on before you dive right in, to think about which tools you're going to be using to do this. So let's take a look at the SolidWorks design workflow. And again, keep in mind, this is just some of the products and solutions that SolidWorks offers for this design workflow. As we saw before, you'll have an ECAD integrator. This will be your electrical engineer using PCB board layout tools or electrical schematic tools. You'll then want to integrate that with your mechanical design to create a physical model of your PCB boards or your wiring harnesses. These then are integrated throughout the 3D design and documentation process. This is designing the entire product, creating the 2D drawings, etc. While you're doing this, you're going to want to look at different simulation results. For example, looking at plastic injection molding, flow simulation, stress analysis, etc. And you'll notice that this is a very back and forth procedure. SolidWorks, as we'll see in a moment, allows you to look at simulation results and make changes before you get to finished production. Then you need to tie into the manufacturing process. SolidWorks provides a variety of outputs for manufacturing, which is extremely useful. And then finally, your technical documentation, things such as instruction manuals or communications with customers, suppliers, etc. So let's go ahead and tie this all together then with product data management. This is really the key to bringing this all together. We need to manage all these different engineering disciplines in one place. So let's go ahead and let's take a look at how SolidWorks solves these problems and look at creating an internet connected refrigerator, creating a smart display for it. SolidWorks is an extremely powerful tool, enabling engineers and designers to realize their ideas in full 3D. In this case, however, we want to take an ordinary ice maker on this refrigerator and web enable it. This is a lot more than just adding an LCD screen, however. There's a lot of electrical components that are going to need to support this system for RFID sensors found throughout the design. And SolidWorks is a great tool to do this. But where do we start? In SolidWorks Enterprise PDM, we can store all of our files in one central location. And with powerful search tools, it's quick and easy to find any design that we're looking for. In this case, we want to work on the smart display. Once it's open, where do we start? We're going to want to go ahead and take a look at this PCB board and get the information to the electrical engineers. SolidWorks' built-in library connects with the 2D electrical engineers' data, meaning that anything we do in 3D can be brought over. We simply need to choose to export it to SolidWorks and follow the guided wizard. In this case, we do need to tell it where the PCB board's main face is and find a few different things, such as do we want to select the outline or let SolidWorks generate it for us? Then we want to find our non-plated holes and our plated holes in our designs. And finally, we can specify any important areas such as keepouts in our designs. Once this is done, it opens up inside of SolidWorks where we can review everything that we've created in the 3D environment before we export it off to the ECAD tools. You can see that filters make it easy to evaluate our designs and make sure everything's right, and when we're ready we simply choose to sync it with ECAD. We can even add a note letting the electrical engineer know what our design intent was. They'll be able to see all the information such as the plated and non-plated holes and make any adjustments as necessary. There might also be changes to the 3D model we need to make right inside of SolidWorks. For example, getting rid of an interference is quick and easy. But once all these changes are done, how do we relay them to the rest of our organization? Enterprise PDM again is built right in, and all we need to do is check this document in and it immediately starts to go through a workflow. In this case, we've submitted it for approval and we can see how it travels through the rest of our organization. Once a change is required, it goes into pending approval, and then an engineering manager needs to finally approve this design. Here we'll log out and log back in as somebody with an engineering manager's privileges. They get a notification that there's been a change. They can view the change with the eDrawings viewer quickly and easily, making sure that all the changes have been made properly. Finally, all that's left for them to do is choose Approved and add a note. Once this is done, this design is ready for manufacturing at this point. But there's a lot more that needs to be done in the refrigerator design. The electrical wiring harnesses that connect to everything need to be incorporated. And SolidWorks Electrical makes it easy to quickly find projects by simply searching for them, and then using powerful tools we can simply drag and drop existing electrical schematic components into our designs and make changes to them. We can block out specific areas if they're going to be found in unique parts of our designs, and we can simply drag and drop other electrical components wherever they need to be added. Here we need to add a grounding wire, so we'll simply search the massive symbol library included with SolidWorks Electrical and simply drag and drop this out onto our electrical schematic. Once this is done, SolidWorks Electrical helps us lay all these components out in the 3D environment. Automatically generating the harness, we can go in and make any adjustments or tweaks and changes as necessary. We have the 2D electrical schematic, but for manufacturing we might want a pin board diagram to be used on the shop floor. Any electrical harness inside of SolidWorks can be flattened using annotative or manufacturing practices. In this case we chose manufacturing. We can always return to the full electrical harness at any time. It's not just the electrical components though. This part was unique in that it required a very specific plastic shroud. We've added a speaker in this case and need to add a speaker grill to our design. SolidWorks has unique plastic tools to aid in this process, further simplifying the design, eliminating the need to create lots of complex features. Here you can see we enter some basic parameters and the speaker grill is complete. There's also mounting bosses and snap hooks as well. Here we might want to add some snap hooks to snap this into the sheet metal cover of the refrigerator design. Like before, you enter some basic parameters and let SolidWorks do all the hard work for you. But once those plastic parts are designed, we need to verify that they're going to be manufacturable. And SolidWorks has a host of tools including draft analysis to help us find problems, as well as undercut analysis. In this case we can see there's really no problems except for the snap hook that we've included, but that's an intentional undercut on this design. Finally, we want to see how this part will perform when being plastic injected. SolidWorks Plastics allows you to quickly create a mesh of your plastic part and evaluate different design ideas. For example, where you might want the injection location to be on your design could affect the overall fill. When you're done, you can always evaluate the results to get a better understanding of how your plastic parts will be manufactured. There's a lot of information that can be gathered here that's going to be critical to the success of your design. Finally, we might want to collaborate all of our changes, and eDrawings is a great way to do this. All we need to do is simply say publish an eDrawing and email it off. Once the recipient receives the eDrawing, they can measure and mark up and add comments to this design. Here's that initial interference we saw earlier. In this case, somebody spotted it and they were a little bit concerned about it. They can easily just add a comment to this eDrawing and email it back to me so I can see these changes. Finally, you might want to create some great graphical representations of your design once it's all finished. And PhotoView 360 is a great way to create beautiful renderings of your design. It's very powerful, leverages multiple cores, and can even use multiple computers on the same network. And as the renderings are completed, you can use them to really convey your ideas to others inside and outside of your organization and use them in marketing materials. As you've seen, SolidWorks provides many solutions for bringing your designs from a simple idea to a completely realized manufacturable design. In this case, we took a simple refrigerator and made it web-enabled for the Internet of Things. Alright, so I think everybody has an idea of where SolidWorks falls in the tools that it brings to the table for designing these internet-connected devices. So let's go back and look at that timeline and let's review what some of these tools were. In ECAD, you're going to have solution partners for creating PCB board designs and things like SolidWorks Electrical Schematic to create your 2D electrical schematics. We then have CircuitWorks and SolidWorks Electrical 3D to bring this information into the traditional 3D design and documentation environment, which is really our sweet spot, SolidWorks Professional and SolidWorks Premium. Then throughout this design process, you're going to want to look at validating your designs, and some tools here might be the SolidWorks Simulation suite of products or SolidWorks Plastics, for example. And then going off to manufacturing, SolidWorks has many great partners, but again, SolidWorks Plastics will provide valuable insight into manufacturing. And then finally, communicating with the outside world is really the domain of tools like SolidWorks Composer and eDrawings. And as mentioned before, product data management, tying this all together, is really handled with SolidWorks Enterprise PDM. So, one more poll question here. What is your level of interest in SolidWorks solutions based on what you've probably seen today or where your company stands? Again, I'll give you a few minutes to answer these questions and then we'll take a look at the results. All right, it looks like a lot of people have a general interest. Some people are just browsing. A good portion of you are evaluating products, and a handful of you are definitely ready to make a decision. That's great. So at this point, what we'll do is we'll open up to some Q&A. I'll be going through and we'll answer some of the questions that we saw throughout the presentation.